EXD, EXE, EXI, EXP. I've heard these terms before, but don't really know what they mean. Flameproof, increased safety, intrinsic safety, and pressurization. They all mean the same, right? They all operate in the same way, don't they? Of course not. Hello and welcome back to the Explosion Protection Professional ExPP Micro-Learning Series. I'm Bob Johnson, your learning facilitator and guide through the world of explosion protection. In the last video, you learned about the critical criteria for selecting EX equipment in hazardous areas. Today, we'll cover some of the most common protection concepts, understanding their differences, and the ways to operate them to ensure safety in explosive atmospheres. Why is it essential to understand what they mean and how each can play a crucial part in providing a safe operation? In one of our first videos, we spoke about the explosion triangle, where we needed a combination of a gas vapor mixture and ignition source and air or oxygen for an explosion to occur. Each one of the protection concepts operates on the principle of eliminating or removing one or more of the three legs to keep an explosion from happening. Let's start with flameproof, commonly referred to as EXD or now EXDB. This is where we take ignition-capable equipment such as contactors, circuit breakers, printed circuit boards, and place them inside of a heavy cast flame-proof enclosure. These enclosures operate on the principle that we will not remove the legs of the triangle, but contain them inside an enclosure which, when and if an explosion occurs, will release the pressure from the explosion and not ignite the surrounding atmosphere using flame paths that cool the hot flaming gases to a temperature below the ignition temperature surrounding the enclosure. This is one of the oldest protection concepts in the world, and it's still widely used today. These enclosures will be identified using cast metal construction with bolted-on lids or screwed-on covers that operate as flame paths. One of the downsides of this technology is the weight, ease of maintenance, and how easily the protection concept can be defeated based upon damage to the flame path. Another widely used protection concept is the use of what is called increased safety, referred to as EXE or now EXEB. In this concept, we place non-ignition capable equipment such as terminal blocks, switch modules, or other EX certified components inside an enclosure and maintain certain creepage and clearance distances between our electrical circuits. These enclosures will typically be similar to a general purpose type of industrial enclosure manufactured from a sheet steel or possibly a glass reinforced polyester style enclosure. These types of systems are typically much lighter and easier to maintain than the traditional flame-proof type enclosures and are commonly used with light fittings, terminal boxes, control stations, and similar products. Another widespread protection concept is the use of intrinsic safety. Unlike flameproof or increased safety, intrinsic safety keeps the electrical arcing components below the minimum ignition curves for the gas group encountered. It's an energy limiting concept and is commonly used for control circuits and sensors that monitor the process. It also entails using not just the end device, such as a sensor or transmitter, but also an associated apparatus commonly referred to as an intrinsically safe barrier. This barrier limits the energy exposure in a flammable atmosphere and removes the ignition source from the explosion triangle. While this concept is widely used since it is energy limiting, it generally is and cannot be used on power circuits for things such as motor starters, light fittings, and other high energy devices. It also requires matching the field device with the associated apparatus to make sure that the equipment in the field operates. Still, it does so safely without releasing energy above the ignition energy required to ignite the atmosphere. Other concepts like pressurization, EXP, operate on the principle of excluding the gas atmosphere from coming into contact with ignition-capable devices, as does the concept of oil immersion, or EXO. Concepts like encapsulation, such as EXM, incorporate switching components such as relays in a potting compound, which again removes the flammable gas or vapor encountered in an ignition-capable device. It is also essential to understand that not all protection concepts suit all zones or gas groups. Certain protection concepts are only suitable for particular zones or are limited by equipment construction for certain gas groups. In the Advanced ExPP Competence Program, you will learn all the protection concepts in detail, along with each methodology's advantages and disadvantages, pros and cons. So now you have a better understanding of some of the most common protection concepts used in industry today. For those of you who want to learn more, feel free to visit academy.bartec.com, your digital learning hub. Subscribe and enjoy our learning offering in explosion protection awareness and competency. Follow us on LinkedIn. Subscribe to our YouTube channel and visit bartec.com. Reach out to me and I will personally answer your questions. Thank you for joining us today. In our next video, you will learn about the properties of different flammable gases typically seen in hazardous environments and how we group them.
If you want to go beyond explosion protection awareness to reach a higher level of competency and compliance, please visit our Academy website. Email at academy@bartec.com, call us at 281-214-8542, or reach out to any of our partners and BARTEC offices worldwide. It would be our pleasure to send you the brochure and information about our digital and in-person explosion protection professional competency certification program. You will receive a BARTEC Academy ExPP certificate and have the option to obtain your IEC EX certification of personnel competency for you and your whole team.